All right, let's get to it. Welcome to Tuesday morning, everybody. We're going to talk about money today. Money, 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 money. Quick graph right here. Listen, all of us have, I'd say nearly all of us have savings accounts. If I was in class, I'd ask with a show of hands whose parents got them a savings account when they were a kid. I would imagine most of your hands would go up. So let's see. When I was a kid, general savings accounts, or at least the one I had an interest rate of 2%, which means if we put $100 in the bank for me when I was a kid, at the beginning of the next year, at the end of that first year, beginning of the next year, I would have a whopping $102 in the bank. 2% of $100 is $2. So for doing absolutely nothing, I would gain $2. The average savings account interest rate now, I think, is 0.005%. So if you have $100 in the bank now and you just let it alone at the end of the year, you'd have a whopping $100.50. Sorry, you're still making money though. Anyway, let's move right along. Compound interest, money builds on itself. So you might start with a little bit of money and then that money builds on that. So then next year you gain, let's go back to 2%. When I was a kid, you're not gaining 2% on $1,000 anymore because you're starting with 1,000 in this example. Now you're taking 2% of $1,020, and then you're gaining on that, and then you're taking 2% of that new amount, 2% of that new amount, 2% of that new amount, and it begins to build on itself, and you get an exponential growth curve. And here is the equation that represents exponential growth in terms of money that's compounded annually. We'll talk about this annually part. That means at the end of the year, they just lop on the 2%. So what do these words stand for? A stands for the accumulated amount after a certain period of time. P stands for the principal. Just like with population growth, it's your initial population, or it's your initial dollar amount. R is like the K from yesterday. It's your interest rate. And just like every day we worked on it, the interest rate has to be written as a decimal. And last but not least, T is time. So let's read an example and let's do this here. Suppose you invest $5,000 in an account that earns 1% compounded annually. If you make no withdrawals or deposits to the account, how much will you have after 10 years? I see that it's compounded annually, even though I'm underlining that. It's going to become important for the next example. So P, the principal, is $5,000. R, the interest rate, is 1%. But as a decimal, that's 0.01. More people make mistakes converting percentages to decimals than anything else in these problems. Take your time with that. How much will you have after 10 years? So the accumulated amount is going to be $5,000 times 1. Let me scroll up so that you see the equation here. P times 1 plus R raised to the T power. So 1 plus 0.01 raised to the T power. All right, so let's go to our calculator feature and let's find out the answer here. So 5,000 parenthesis 1 plus 0.01 raised to the 10th power. $5,523. Now this is money, so unless it says otherwise, round to the nearest penny. So 5,523 and 11 cents. 55.23.11. So equals, don't forget the dollar sign, 55.23 and 11 cents. And that's it. Now, this was a basic example. In reality, I'm going to come on camera for just a second. In reality, at the end of the year, they don't just give you one lump percentage. Believe it or not, what they do is throughout the year, they chop up your interest rate. Let's say this whole slice in between my hands is your whole interest rate. They might slice it up. Actually, I slice it up into 1, 2, 3, 4 pieces. And instead of giving you one whole percentage at the end of the year, 3 months in, they give you a quarter of the percentage. Another 3 months, they give you another quarter percentage. Another 3 months, they give you another quarter percentage. And another 3 months, they give you another quarter of percentage. So what's a quarter of 2%? It's 0.5%. That means at the end of March, they add 0.5%. April, May, June, the end of June, they'll give you another 0.5%. July, August, September, they'll give you another 0.5%. And then at the end of December, another 0.5%, which adds up to 2%. Now you might say, nah, I just want my whole 2%. Believe it or not, chopping it up helps you. And that's called compounding. So in reality, this is the formula that you're really going to deal with through this entire lesson, this formula. It's the same as the formula directly above. It's the same exact thing as the formula directly above, except we're dividing the interest rate by an n here, and we're also multiplying by n. Do you see that? What is n? So P is still the principal. R is still the annual interest rate. N is the number of times that your money or your interest is compounded per year. T is the number of years, and A is the accumulated amount. So N has 3 common values. If you see in the word problem that something is compounded annually, annually means once a year, so N would equal 1. If your money is compounded quarterly, quarterly means 4, so that means N would equal 4 times per year. And last but not least, if it says that your money is compounded monthly, that means they're slicing up the interest rate into 12 pieces and giving you 1/12 of your interest every month. So N equals 12. These are the 3 values of N that you need to focus on. So let's get down to the first problem right here. An amount of $1,500 is deposited in a bank paying an annual interest rate of 4.3% compounded quarterly. I'm going to underline the word quarterly. Find the balance after 6 years. So I'm going to write P equals R equals N equals T equals. For every one of these problems, you can do P, R, N, T. The principal, $1,500. The interest rate is 4.3%. How do you change a percentage to a decimal? Take that decimal and move it 1, 2 places to the left. Don't forget to fill in a 0. So it's 0.043. Always 2 places to the left. Because your money is being compounded quarterly, quarterly means N equals 4. Just above, if I scroll up just a little bit, compounded quarterly, N equals 4. And last but not least, time is 6 years. So what will I do here? I'm going to say that my accumulated amount is equal to $1,500 times 1 plus, let me scroll up just so that we get a better glimpse of the formula. It's 1 plus R divided by N, and then raised to the power of N times T. So 1 plus R, which is 0.043, divided by N, which is 4, raised to the N times T power. So that's 4 times 6, which, by the way, 4 times 6 is 24. Sometimes it's helpful to do a little bit of pre-work so you don't have to work it all out. All right, let's go to our calculator. 1,500. 1 plus 0.043 divided by 4. So I'm going to take 1,500, parenthesis, 1 plus 0.043 divided by 4, close the parenthesis, raised to the 24th power because it was 4 times 6. That's it. Oh, did I mess up here? Yes, I did. It was 1,500. Can I go back? Yeah, just clear. 1,500. 1 plus 0.043 divided by 4 and to the 24th power. There it is. And if I hit enter, I get $1,938. And will it be 83 cents or 84 cents? 84 cents, Mr. Cody. That's right, 84 cents. Why? Because this 6 is bigger than a 5. So 1938, 84. 1938, 84. 1938, 84. And that's all she wrote for that problem. Okay. I'm going to do one more problem with you because I think you're going to get the gist of this right now. An amount of $2,300 is deposited into a bank paying an annual interest rate of 5% compounded monthly. Find the balance after 30 years. So I'm going to write P equals R equals N equals T equals principal $2,300. Interest rate 5%. As a decimal, that's 0.05. N compounded monthly. So N equals 12. Last but not least, the balance after 30 years. Oh, we're going to make some money here. All right, so the accumulated amount after 30 years is $2,300. And then 1 plus the interest rate, 0.05, divided by N, which is 12, to the 12 times 30 power. If you want, you can keep 12 times 30 just the way it is and do it on the calculator. So 2,300, 0.05 times 12. So 2,300, 1 plus 0.05 divided by 12. Close the parenthesis to the power of 12 times 30. Notice this is oh, by the way, this is the smart technology that I gave you guys the license to, or the website to get the license for. If you don't have a calculator at home, just go click on that website and get a license code and get this on your calculator or get this on your computer. You'll have the exact same technology I have right now. I did this just the other day. Wow, started off with $2,300 and we ended up with $10,275.81. 10,275.81. Wow, wow, wow. 10,275.81. Wowie zowie. And this assumes that we're not putting any new money in. That's it. All right, folks. That's it. I mean, I only did 3 total examples, but more might be redundant. We did one example where things were compounded annually. By the way, this, if I really thought about it, could be divided by annually, which is 1. And then it would be 1 times 10, if you really think about it, because it's annually compounded. Then compounded quarterly, we did an example where we divided by 4. Then we did one example where we compounded monthly, which is divided by 12. One of each. Everybody, ask questions if you have them. Bye.